This video is a brief summary of right angle trigonometry. So with these calculations, we're looking at using sine, cosine, and tangent within a right angle triangle. So each side in a right angle triangle is identified relative to a specific angle when we're doing these kinds of calculations. So some notation that's important: we usually show angles with capital letters and sides with lowercase letters. And it's important to note that the side opposite of an angle has the lowercase letter that's the same as the angle. So we have A right here, and we have the side opposite A across from A. The adjacent sides are the ones that make up the angle without being the hypotenuse. So the hypotenuse is always across from the right angle. So in this case, if we're looking at angle A, the adjacent side is side B. The three main trig functions, as I mentioned, are sine, cosine, and tangent. Sine is equal to opposite over hypotenuse, cosine adjacent over hypotenuse, and tan opposite over adjacent. Note with all of these, it's sine of an angle, right? We've got that Greek letter theta showing our angle. Cos of an angle, tan of an angle. We can't just say sine or cosine in an equation without having an angle there. It doesn't make any more sense than saying square root in an equation without it being square root of something. So to remember these three, people often use the mnemonic so, ka, toa, where so stands for sine is opposite over hypotenuse, ka, cosine is adjacent over hypotenuse, and tan is opposite over adjacent for toa. So for any calculation, when we're figuring out which one we use, sine, cosine, or tangent, first step is to identify the angle involved in the question. So that's either a known angle or the angle being determined. Second step is to identify the sides involved in the question as either opposite, adjacent, or hypotenuse, based on which angle we focused on in step one. Third step is to figure out, okay, do we want to use so, ka, or toa, sine, cosine, or tangent? Once we have the equation picked out, we can then use it to solve for our unknown value. So we can solve for sides or angles as long as we know two of the three parts of the formula. So for solving for a side, we simply rearrange the equation so that the side that we want to know is isolated. When we're solving for an angle, we have to take what's called the inverse function or the arc function of both sides. And remember, the arc function and the function cancel each other out so that we're left with the angle. In my class, and many instructors are similar, minimum amount of work to show formula of the correct function, rearranging that to isolate the value that we need to know, substitute all values into the formula, and the final answer. Now often those rearranging steps, you can do them in multiple steps or you can do it in one big step, but it does need to be shown somehow. So I've got three examples that we're going to look at. So first one, we've got an angle and a side, and we're asked to find the unknown length x. So if angle x is right here and it's 58 degrees, across from that we have side x. So if it's across, it's the opposite side from our angle. And the other one we know is across from our hypotenuse, so that's, across from our 90-degree angle, so that's our hypotenuse. So if we know opposite and hypotenuse, the formula or the function that we want to use with opposite hypotenuse is sine. So we rearrange that. So if we want to get opposite alone, because that's what we're looking for, we've got to multiply by the hypotenuse to bring it to the other side. Then we can plug in the values we know. So the hypotenuse is 145. The angle theta is 58. The side opposite is what we're looking for. So there's our x. Calculate that with your calculator. And we find that x is 122. And there's a lot of decimals here. So go back to the original question. It says round to 3 significant figures. So we would round that to 123 centimeters for our final answer. For the next question, you might want to pause the video after you look at the question and try and solve it on your own. So this time we're looking for an angle. So compared to that angle, we know the opposite side is 15 centimeters, the adjacent side is 58 centimeters. So opposite and adjacent, that's our TOA or tan. This time we're looking for the angle, so we've got to do that arctan step. And remember, arctan and tan cancel, so that'll leave us with theta on that side. And theta equals arctan of the opposite side divided by the adjacent side. So we do that calculation. And this one's to the nearest degree. We get 15 degrees. Last example, and again, you might choose to pause the video before you look at the solution. We want to determine R. So remember, side R is going to be across from angle R. So it's that side right there. So if we look at the angle that we do know and label the sides we know and the side we want to know, compared to that angle, the 58 is the adjacent side, or side P, and side R is the hypotenuse. So if we have adjacent and hypotenuse, that's our ka. Use cosine is adjacent over hypotenuse. So we rearrange that to solve for the hypotenuse. So that's, for most people, a two-step calculation. First we have to multiply by hypotenuse to get it out of the denominator. But then we have hypotenuse times cos of theta. So to get rid of cos of theta, we divide by that. And we get hypotenuse is equal to adjacent over cos, which in this case is 58 divided by cos of 25 degrees. When we calculate that value, 63.995, etc., it says to the nearest tenth, so we're going to round that to 64 centimeters. So there's a few quick examples to summarize right angle trigonometry.